So now we'll be starting our motion of projectile on an inclined plane. So I have an inclined plane which has an angle of inclination alpha, and I'm throwing a ball with the initial velocity u at an angle theta with plane. So it's going to follow a path like this. Now my task is to calculate the time of flight, the range, which is p2q distance, and the maximum height. Same things. So I'm not taking my x and y axis like we have taken earlier, not like this, but I'm taking x axis along the plane and y axis perpendicular to that. So if the velocity is u along like this, so in along x axis our initial velocity is u cos theta, and along y axis it should be u sin theta. Now for time of flight, I have to consider the motion along y-axis. So taking again the motion of shadow along y-axis, that is from P to B dash and from B dash to P. You have to take the whole motion. So for that, our initial velocity is u sine theta. And interesting thing is the displacement is zero. So using that same thing, displacement is zero, initial velocity is u sine theta. Here, acceleration along AY means acceleration along this particular axis is not g. So g is along this, like this, g is there. So this angle is again going to be our alpha, which is parallel to our y-axis. This is going to make an angle alpha, as this is alpha. This is going to be your 90 minus alpha, and this is going to be your alpha. So along this axis, our acceleration due to gravity is g cos alpha, and along this axis, it is g sine alpha. Now there are, I'm putting the value of g cos alpha in the time of flight in this particular equation and get my time of flight, 2 sine theta over g cos alpha. But there is one more thing here to note, that the acceleration along x-axis this time is not zero, so the motion is not uniform here. So this time it's going to be accelerated, and the velocity is going to change along this axis also. But the time has came to u sine theta over g cos alpha, and we have learned from the same level to same level projection that time comes out to be 2u perpendicular over e perpendicular, and the same formula is applicable here also. Here u perpendicular is that component of initial velocity which is perpendicular to plane, means that portion of component of initial velocity that is perpendicular to plane. So this is our plane, and perpendicular to this is u sine theta. So that I have replaced here, u sine theta, and a perpendicular is nothing but g cos alpha. So this equation holds here also. Now let's calculate the maximum height attained by the particle with respect to the plane, means from here to here. I'm talking about the maximum height. So for that also I'm taking the motion along shadow and half motion, that is from P to B dash y-axis, and here the final velocity would be 0 using that same concept. Final velocity is 0, uy is u sine theta, and ay is g cos alpha, negative g cos alpha, and h I can simply calculate. Again, it's come out to be in the same form as u perpendicular square over 2a perpendicular. So u perpendicular is u sine theta, a perpendicular is g cos alpha. Now let's calculate the range. Range would be the distance from P to Q, and for this only we are taking the motion of shadow along x-axis, and this time our acceleration along x-axis is going to be negative of g sine alpha, and the initial velocity along x-axis would be u cos theta. So sx would be our plus r, ux I have told, u cos theta, time we have calculated to u sine theta over g cos alpha, and this would be our value of r, the range. Now for range to be maximum, dr over d theta is going to be 0. So when you do that, you get to know that theta, when theta is pi by 4, means 45 minus alpha over 2, at that angle, the range is going to be the maximum range. So this we can remember because we don't have time for differentiating this with respect to theta. So this is it for range. Now we have to see equation of trajectory.